Hey lads, prove the following. 1 minus cos squared A equals sine A over cos A. No bother. When I see a 1 and a cos squared A, straight away I'm thinking number 5. And what can I do with number 5? In the cos squared A over the other side, and what do I get? Huh? Yeah, exactly. So what can I change that to? Sine squared A. Now sine squared A means sine A multiplied by sine A. Would that be alright with you guys? Alright. Next thing. We have tan A here. Now what cancels on the left side? Sine A divided by sine A cancels. And what's left over? Which is rule 3, isn't it? And then I can just get tan A equals tan A. Alright. Are they getting a bit easier? Hopefully. Alright. Now, let's have a look at this one then. 16. Oh, there it is. Now, once again, I'm looking at 16 and I'm going, do you know what? What can I change 1 minus sine squared A into? Yeah, we can do the same thing we did a second ago, couldn't we? Bring the sine squared A over to the other side and we get cos squared A equals 1 minus sine squared A. So we have that as cos squared A. That's tan squared A. Oh, that's a cheeky one. There's 2 different ways to do this. Alright. How many people subbed out tan A for sine A over cos A? Is that what you guys did? Yeah, I think that's the best way. I'll show you 2 ways, alright? I'm going to say that tan A equals sine A over cos A. In that case, what's tan squared A? Exactly. So I can say that that's cos squared A multiplied by sine squared A over. Is that okay with you guys? Now what can we say next? Cancelled. And what's left over? Which is rule 5, so 1 equals 1. Did anybody do it a different way? Is there any need for me to do it a different way? Does anybody see a different way of doing it? What happens if you factorise out cos squared A? What's left over? Would you all agree with that? Do any of you see this in any of the rules? Which rule do you think it is? I think it looks a lot like rule 6. Do you see rule 6? 1 plus tan squared A. That could be the same thing as tan squared A plus 1. So what can I put in here? Yep. Secant squared A. And what does secant squared A mean again? Yeah, exactly. So you're going to get cos squared A multiplied by. None of you went down that route anyway. And they both cancelled to create 1. Many different roads to take to do these questions. Alright. Everybody cool with that? Now what am I on now? 20, yeah? Now, here's what you're going to do. These are all cosine rules at the moment, aren't they? Yeah, we should probably do the sine rule ones as well in a few minutes. Alright. This ain't so bad. Right? Now, I use what's called the interchange technique. Right? Here's the interchange technique for you in a nutshell. When you go to your tables, what do you see? You see a squared equals. You see a squared equals b squared plus c squared minus 2bc cos a. Now here's the first thing I want you to do. Ready? Anywhere you see an a, reverse it with a b. Anywhere you see a b, small b, reverse it with an a. Anywhere you see an a, you reverse it with a b. So does everybody understand? C stays exactly where it is, but a's and b's completely change position. Is that alright with you guys? Adam, what do you think you're going to get? What will be here? Yeah.
equals a squared
Yeah.
plus c squared
Yeah.
minus 2ac
Yeah.
cos b.
We cool with that? Now let's go for another variation. Just while we're here, let's switch out b with c, small c with small b, and capital B gets switched out for capital C. So Joe, what happens this time?
I don't know.
Read the list. That's a small b. What does small b get changed for?
C.
So what is it?
C.
C squared. A, is there any A's up here?
No.
Leave it alone. Small c,
B.
small a,
Should stay the same.
yeah, small c,
B.
and big B.
Big C.
There you go. You got the three variants or the three variations of your cosine rule sorted. Now here's what we're going to suggest you do. Does everybody see BC cos A? Does everybody see BC cos A here? I have no idea. Let's move the 2BC cos A to the left and move the A squared to the right. Quivian, what's the next line to read then?
2bc cos a squared
Equals what?
b squared plus c squared.
And where's the A squared gone? Was on the left.
Oh, you take the right and minus a squared.
Awesome. Okay. What can I do there? I want BC cos A. I don't want 2BC cos A. So what you reckon?
Bring the 2 down.
What you get?
B squared plus c squared minus a squared over 2.
Now, you can do exactly the same thing for CA or AC, can't you? Does anybody have a quicker way of doing it? You could just interchange it again, couldn't you? Because you're going to do exactly the same trick, so why bother doing it twice? So, what we want here is instead of A, what do we want? B. So any B's turn into A's and any A's turns into B. Let's do it. B turns into? Capital A turns into? Sorry, capital A turns into B. Small b turns into? What? Small b turns into A. Small a turns into? That's a lot quicker than doing it from scratch, isn't it? Alright? So what can we do with the two answers then? What can I do with this red part here and this blue part here? I think I'm going to add them, haven't I? I think you're completely lost, are you?
Yes.
Which part specifically are you lost on? The interchanging? You're not happy about it? Alright. In that case, can I go all the way back here? Were you okay with the three of them?
What's the point in them?
Why are you changing it?
Why am I changing them? Okay, good point. The reason why I'm changing them is, see the way it says cos A? I know I have to use this one because that's the only cosine rule that has a cos A in it. And then see the way this one has cos B?
Yeah.
I know I need this one because that's the only one that has a cos B in it. So I know that I have to change my generic equation so that it has cos B in it and not just cos A. Does that make sense so far?
Is that in our tables book?
Huh?
Is that in our tables book?
One of them is, the green one is, and you need to be able to make the other two just by interchanging your letters. Is that okay? Green one's in your tables, the other one isn't. Now, what we said earlier was that if you look at the letters that comes in front of it, look at your targeting. See the way it says BC cos A? Well look, there's BC cos A right there. So if I isolate BC cos A, I have exactly what's needed. And likewise, CA cos B. Well, that's the same thing as AC cos B, isn't it? If I isolate that, I get exactly what I'm looking for. Are you with me so far? Alright. Now what did we say earlier? Bring the A squared to the right and the 2BC cos A to the left. So what do we get? And then what did I do with the 2? Huh? Bring it over. We cool? Alright. Next thing. Do you want to do the same thing for the bottom equation then? You have a choice. You can interchange or just do it all out again. Do you want to give interchange a go? Alright. Instead of A, what do you want? All A's and B's interchange. That's how we know to do that. So what do you reckon, Queevin? B turns into?
A.
Big A turns into? Small b turns into? Small c? Small a? All over? 2. Is that alright? Now what do I do with the 2 of these now? What can I do now? Just sub them in, don't I? And what do I get? B squared plus c squared minus all over. And here? Now what cancels? Cancel with that. Cancels with that one. And what's left over? 2c squared over 2. And what's the answer? Off you go. Yeah, it's grand, is it? Alright. Now, with 22, given what just after teaching us about 20, what do you reckon would be a good idea for 22? So, what 2 variants of the equation will I need to write down? What, a squared? What else? Minus? Now lads, look at this. You ready? How do I know I needed this one? How do I know I needed that one? It says cos A, doesn't it? Right. What parts do I want on its own? I want the B and the cos A on its own. That means I want the B and the cos A to stick together. We're going to do exactly what we did last time. What did we do last time? We flung it to the left. And then what did we do after that? Alright. What do I want to keep here? I want to keep the B and the cos A. So what needs to go? I don't fancy doing that again. So you just write down interchange. And can we interchange it for A cos B? How would you do that? Anywhere you see a B? So A cos capital A, B, small b, C stays there, small a, and isn't that much quicker? Not having to go through all that again. Okay? Now we have both answers ready to go. So what happens when we take both of these answers and add them together? I think you guys need a bit of class time trying this stuff out, to be honest. Alright Joe, what happens when you add the 2 of these together? Oh sorry, you're taking one away from the other. This is awkward then. See the minus? It makes it awkward because you have to minus the top. Alright, that makes things really awkward. So what happens there, Joe, to this part here? Minus squared, yeah. Then
Plus minus c squared.
minus c squared, yeah. And minus times minus.
Plus.
So what cancels then? What cancels? Stop giving them wrong answers. C squared cancels with?
C squared.
Minus c squared. Minus a squared and minus a squared gives you what?
Minus 2a squared.
Thank you. And b squared plus b squared.
And 2b squared.
And there's a 2c on the bottom. What could you do top and bottom there? Top and bottom in the blue box. What could you divide out? Factorize out 2. and you get 2 into b squared minus a squared all over 2c. So what cancels?
Two.
The 2's cancel. What are you left with?
B squared minus A squared over C.
Anybody get it? Oh, this is the wrong way around. Oh. Oh, it's so annoying. Do you know what I did? I swapped them around the wrong way. So if I just multiply my answer by minus, it'd be grand. But look, sorry, my bad. What should have been done? Sorry, should have went back a couple of steps here. Sorry, lads. I just put them in the wrong place. So everything is perfect here. And guess what I did? Sorry. That one should have been the one on the right, and that one should have been the one on the left. The fact that I got the opposite, that means that that's what happens. When they're in the opposite order, it means you should have put one of them in front of the other one. You got it the opposite way around. So that's a useful skill in identifying why you went wrong. Okay. So look, we'll go again. My bad. Okay. What did we say earlier? That turns that into what? Minus b squared minus c squared plus. So what cancels? The c's cancel. What's left over then? Minus all over, and then just divide by 2 and you get, yeah. Look, mistakes will happen. It's being able to spot them is the deal. Alright guys, what's on the next one? Alright lads, you're going to try one or two of these now and I'm going to take a break.